In this video, we'll discuss linear regression training, i.e. how to get the parameters. In particular, we'll talk about the loss function. We would like to determine the parameters for a simple linear model. Let's start off with a simple example with just one sample as shown in the graph. The value for x will be -2 and the value for y will be 4. We'd like to come up with a slope and bias for our linear model. Unfortunately, this problem is overdetermined, i.e. there is infinite number of lines that will cross at this point. So let's simplify the model by just trying to determine the slope parameter. In order to find the parameter, we need to find how good our model is. We need a quantity that is near 0 when our model provides a good estimate, and large when our model estimate is bad. We call this quantity the loss. We do this by subtracting our model estimate, in this case y hat, with our actual value, y. We are essentially finding the distance from our model estimate to the actual value we are trying to predict. We would like to determine the parameter, in this case the slope, that minimizes the value. This is actually a function of our parameter. In the training phase, x and y are given, so in the final form, our function looks like this. This is referred to as a criterion function or loss function. The goal is to determine the parameter that minimizes this function. And just a little side note, there are different types of loss function that we will cover in this course. The table on the right has two columns. The first column is the value of the parameter, and the second column is the loss generated by using that parameter. The table on the left will show some lines generated by using that value of the parameter. If we select a value for a parameter of 5, the loss generated is 484. We see the line generated on the left. If we use a parameter value of 1, our loss is 36. Our line gets closer to the data point. If we use a value of the parameter of -1, our loss is 4, and our line is extremely close to the data point. Finally, at 5, our line diverges, and the value of our loss is 324. It's difficult to come up with random values that minimizes our loss function. So let's come up with a more systematic way of minimizing our loss function. It's helpful to display the loss function on the right. It's shaped like a concave bowl. This is sometimes referred to as a parameter space. The left contains different lines corresponding to the parameter. If we select the slope of 5, we see the loss function has a relatively high value, and the line is quite farther away from the actual data point. If we select a value of 1, we see the value is relatively low in the loss function, and the line gets close to the data space. If we select a slope of -1, the value is much closer to the minimum of the loss function. We also see the line is much closer to the data point. Finally, if we select a slope of -5, we see the value generated by the loss function is quite high, and the line is further away from the data point. If we look at the derivative of the loss function, we see it is negative on the left side of the minimum, and positive on the right side of the minimum, and 0 at the minimum. We can actually find the best value of the slope by setting the derivative equal to 0, then doing some algebra, and finding the best value for the slope, in this case is -1/2. Unfortunately, for many deep learning models, this is not possible. Let's come up with a better way to minimize the loss function.